All right. Hello and good evening, everyone. My name is Brian Fitzgerald, and I'm the Director of Education here at Mount Washington Observatory. Thanks so much for joining us for another Science in the Mountains program. Joining us this evening to discuss their work investigating extreme weather on social media are McGill University Associate Professor Renée Sieber and Mount Washington Observatory Executive Director Drew Bush. Thanks so much for joining. And for those of you who aren't already familiar with Mount Washington Observatory, we are a private nonprofit organization supported by our members with a mission to advance the understanding of the forces that create Earth's weather and climate. The way that we accomplish that mission is through operating our Summit Weather Station and producing around-the-clock weather observation and forecasting, by conducting research and product testing projects, and by developing and offering innovative educational programs. If you have questions for tonight's speaker and you're joining us through Zoom, make sure you use the Q&A button. You can find that right down at the bottom of your screen on the Zoom window. You can you can enter questions at any point during the program, and we'll make sure to save time to get to those questions at the end here tonight. If you'd like to connect with us for another program, an upcoming Science in the Mountains program, make sure to register over at mountwashington.org for our next one. Alrighty, well, before we kick things off and hand it off to our speakers tonight, we did put together some poll questions for those of you joining on Zoom. I'll go ahead and launch those right now. 4 questions for you this evening. You should see those popping up on your screen. The first one, we're curious where you're joining from this evening, perhaps somewhere within New England, one of the states here in New England. Perhaps you're joining outside of the region. Perhaps you're joining from outside the country. I know at least one of our speakers is this evening. So please feel free to share where you're joining from tonight. And then we have a few trivia questions for you. The first one being, the study of computer algorithms that improve automatically through experience is termed what? Is it compilation, formulation, machine learning, or artificial intelligence? Question number 3, how recently was the term artificial intelligence coined and study of it begun? Was it 1912, 1956, 93, 2012, or 2020? And finally, what are similarities between regions of Canada and Mount Washington Summit? Is it latitude, altitude, climate, or welcoming people? Looks like quite a few of you have had a chance to participate. I'll give you just a few more seconds here to respond if you wish to do so. And we'll end the poll here in about 5, 4, 3, 2, 1. Alrighty, let's end the poll right there and share some results with everyone. Hey, look at that. The Granite State of New Hampshire, almost a third of you participating this evening are joining from New Hampshire. Good representation from throughout all the New England states, with the exception of our friends in Rhode Island tonight. Quite a few of you, a quarter of you from outside the US of A. And we have more than one Canadian joining us, or a person joining from Canada or elsewhere this evening. A few of you joining from outside the country. So welcome to everybody. Question number 2, the vast majority of you, 55%, thought artificial intelligence was the study of computer algorithms that improve through experience. Number 3, most of you thought 1956 is when the term artificial intelligence was coined and the study of it begun. And most of you think, 68% of you think climate is the main similarity between some regions of Canada and Mount Washington Summit. Well, we'll all have to find out the answers to some of those questions and more here in just one second. So without further ado, I'd love to welcome our speakers for this evening. I know first and foremost, we'll have Executive Director of Mount Washington Observatory, Drew Bush, who will be speaking first before handing it off to Renée Sieber this evening as well. So Drew, feel free to turn your camera on and unmute yourself, and welcome.
Yeah, thanks, Brian. Glad to be here with everybody tonight. And I'm just going to share my screen to bring up our slides. Let me make that full screen.
So great.
Yeah, as I said, really excited to be here with everybody tonight. Have a wonderful presentation to share with each of you on research that I've been involved with for just under the past 6 years. I think the nice part about tonight's presentation is not only do we get to bring to you some really cutting edge research, but also get to tell a little bit about my story as well, coming to the Mount Washington Observatory, and introduce you to somebody who's been probably the most formative mentor I've had in my life, has influenced the way that I think about science and research and pretty much all the work that I do in my daily life. So really excited to introduce you to Renée in a little bit, but I'll be kicking things off with the first few slides here. And as you can see from the title, obviously, we're talking about social media in relation to extreme weather. Perhaps a bit atypical topic for the Mount Washington Observatory. I think often we present in Science in the Mountains on physical science topics. But at the heart of what we're really concerned with is the human relationship to the weather, how extreme weather in particular relates to human society, its impacts, and how humans deal with it and adapt to it. Social media is really a tool that social scientists can use to better understand this relationship. It's one tool among many. It has its advantages, and as I'll talk about in a few minutes, it has its disadvantages as well. But it's a tool that can do things, for instance, like help us to inform forecasters how to make their work more useful. Both those forecasters that work here with us at the observatory on the summit, and those that work in federal agencies like the National Oceanic and Atmospheric Administration, or at Environment and Climate Change Canada, in this case, the funder of this project. It can also help crisis managers, so folks in fire departments and municipalities and elsewhere who have to deal with crises that are created through extreme weather as well. So before I get into those details, I just wanted to jump right into it and give you a sense of kinds of things that we see in this type of research, the kinds of social media posts that we're dealing with. Our research is focused in Twitter, and there's kind of a spectrum. Anytime you deal with social media, as I think everybody in this audience can attest to, there's a wide variety of serious to funny to absurd things that you might find. And so if you're looking at weather or social media through the prism of weather, you might see things with, like on this first slide, that are funny. So one of the data sets we've scraped and collected for our project this year is actually on the storms in Ontario that were taking place. And you can see one person equating it to the size of their golden retriever, or other people posting on their habits during extreme weather, whether it's to buy milk, bread, and eggs, or to head to the liquor store. And there's kind of a spectrum that you see in terms of weather. And so moving from sort of the really non-serious to the perhaps semi-serious, on the left, we're looking at forecasting done by television meteorologists on that same Ontario storm, and equating the severity of the storm to the number of bags of chips and hot cocoa that you need to have to be prepared. So the purple, of course, being the people who need to be prepared for the most severe type of weather that might arrive. But also folks who feel called to duty when they experience extreme weather to serve their communities, as the tweet on the right also shows. Then one of the things that has been a real focus in our work, and that Renée will be talking about in a little bit, is the actual official alerts that are put out. So in the United States, these are primarily put out through NOAA, the National Weather Service, in Canada, through Environment and Climate Change Canada. You can see on the left, tips for people experiencing weather or extreme weather in the city of Victoria. And on the right, just a better sort of overall view of what the Emergency Management Division in this municipality actually does. And Renée will talk a little bit about what we call specific area message encoding tweets. These are tweets that are actually official alerts, and they actually contain data that a lot of what is put out in the popular are quasi-official places. Those include broadcasters as well as other mediaries of this information are receiving, and in social media, participants in these platforms are receiving directly. So this starts to I hope, grab you and give you a sense of what it means to think about social media as it relates to weather. One of the places we actually started this project 3 years ago is thinking about how do Canadians actually talk about weather on social media? What are the types of discourses? How does that play? And here I presented sort of 3 spectrums to you. I should mention that this is actually the second iteration of an Environment and Climate Change Canada grant. The first 3 years, we actually conducted what is called a social network analysis to really even look at the community of people who are communicating on Twitter. And now we're really diving into thinking about how do we make this useful? How do we improve forecasts? How do we provide this information more effectively to people who are impacted by weather? And so in tonight's talk, we're going to start with a little bit of an origin story. As I mentioned, how I got to the observatory and what that means for some of the research that we're thinking about. Why is social media and weather really so important? How does artificial intelligence come into this? And then what are some of the interesting challenges and discoveries that we've had from this research from the past 6 years of it, the most recent grant being these past 3 years that conclude in March. So where did I start? Back when I was an impressionable doctoral student coming to think about these topics, I have to admit, until I met Renée, I was thinking about climate science, and I had been working in Washington, D.C., and couldn't understand why climate science wasn't more popularly understood outside of the city where I lived. And I actually thought of it as a communications problem. I thought perhaps the science is just not clear enough for people. And coming to McGill, I began to learn about it as an educational problem, one that we have to think about in terms of human cognition. And my dissertation work at McGill involved actually giving students and the public an opportunity to work with one of NASA's climate models, so that rather than trying to communicate information, we could give different people the opportunity to be able to actually do their own research in climate science, pose their own questions, and see what types of results they might actually find happen. And so what you see on the screen here is the Educational Global Climate Model. It's actually a model from the 1980s. And what it does is it actually steps through each hour of each day through the grid cells that incorporate the Earth to simulate, using physical equations, all of the processes that govern our atmosphere and its relationship with the ocean and with other variables. Climate models today are more sophisticated than this. They include other parameters, more different variables, and the resolution of these grid cells has gotten even more fine. But for me, really, the key idea here is how do we think about public understandings of topics like climate and weather, and in particular, with the grant we're talking about tonight, extreme weather. When I was a postdoc at McGill, Renée and I started to get much more involved in thinking about meteorology. What you're looking at here is actually a picture of McGill's observatory. So much like Mount Washington Observatory, McGill had an observatory with a historic record that dated from 1863 to 1963, before this building was actually bulldozed. And you'll see an example on the right of the types of logbooks where all of our meteorological data was kept. And these logbooks were that record, just like the observatory in Mount Washington keeps up on the summit, of all the data that's been collected since this observatory started. And so this project is a really truly interdisciplinary project being driven by a colleague of ours who's a historical climatologist. And her driving question was really a need to have this data to be able to do her research to better understand the climate. But the other people on the project included archivists who were interested in this material from a historical standpoint, It included folks like Renée and I, who are interested in understanding the human relationship to this meteorological record. It included physical scientists who are interested in the data for itself. And in particular, we were really still driving at this question of what is the human relationship to weather? How is that important? How does it impact society? And what ways can we use this information to improve the quality of life for people around the world? And so naturally, when I came to the observatory, I began thinking about some of the things that the observatory really offers as this unique resource. How can we think about improving forecasting? How can we think about improving the models that are used for forecasting? And so the Weather Act, which I know our friends at NOAA are hoping will be considered by Congress this year, really focuses in this area too. How do we make our communities safer? How do we prepare them for extreme weather? How do we prepare them for perhaps changes to the local climates where they're located? And how do we do these things while thinking about the ways we can improve the technology, the models that we use to forecast? And how do we do it as well to make these forecasts more useful for the business community, for local towns, for cities? And how do we improve all of these things, which are all areas that now the observatory is really focusing some of its effort in as well. I should mention these are potential funding sources. And so the core question here is translating the work that meteorologists do, like our folks who are on the summit right now in Mount Washington, taking our hourly observations every hour of every day. How do we translate this into a useful product so that, as you see in the image on the left, this kind of situation arises when it's necessary, and so that broadcasters, as you see on the right, can convey the right messages to convey the severity of a situation so that we can have our communities be prepared and we can think about ways to make forecasts specific and tailored to the situations that arise or the place where they happen. And as I mentioned at the outset, one way of doing that is to look at things like social media to really make the connection between crisis managers and our meteorologists that are making these forecasts more direct so that we can bring these two communities of people together. And as I said, social media has a lot of advantages. It's real time. The people who are posting on platforms like Twitter have proximity to the events as they occur. You can find out what people are thinking about, what they're experiencing, if there are power outages, if there's infrastructure damage. But it also has disadvantages. There's a huge amount of content. There's a lot of noise. People like to post pictures of themselves eating ice cream or what they had cooked for dinner that night. And so social media, like a lot of big data sources, suffers from what we call the 3 V's in research. The volume of the data, there's an immense amount of it. The velocity or the speed at which it comes at you, and the variety. Some of it's useful. Some of it is an official alert, perhaps from a government source like NOAA or ECCC. And some of it is less useful. It might be entertaining, but when you're trying to build awareness of a situation, of a crisis that's unfolding, it might not actually contain that type of useful information within it. So what Renée is about to talk about are the methods that research community has been developing to handle these issues and to sort out from social media what can be really useful for our crisis managers, for our forecasters to better understand their own work and how they can refine it and be of better service to their communities, as well as to the people who are impacted by weather. Is there a way that we can communicate this aggregate data to people where they are so that they can better navigate a storm that's impacting their community? And I'll say that this is a really popular area of research. You can see a few example headlines here. Social media and weather We're not the first research group to do it, but AI in particular, as it's become more prevalent in society, has been applied to this topic more and more. And it's an incredibly important area of research for improving this interface between our physical science and our human communities. And I think I'll leave it there and turn things over to Renée.
Hi there, everyone. Thanks so much, Drew. And he didn't reveal any details about how I treated him as my graduate student or my postdoc. Thank you, Drew, for that. So my research is in public engagement in various kinds of computational technology. And the more complicated it is, the better. I started out with computerized mapping, GIS, or Geographic Information Systems, public engagement in that. Then I moved on to how can the public engage with actual climate models? Can they run a climate model? Results are mixed. And I'm now very interested in artificial intelligence, public engagement in artificial intelligence, whether that's the use of AI to help the public engage, whether it is the use of AI by the public to engage, and all sorts of things in between. And in this particular case, I'm very interested in the use of AI to try to sift through the noise to get a sense of how people feel about weather, and increasingly whether or not they're listening to experts about weather or whether they're racing to the store in some kind of panic every time they hear an advisory, whether that advisory is coming from the Weather Network or whether that advisory is coming from an official source is really important. So we're using AI for this, and it's a little bit difficult these days to talk about AI because everyone thinks of ChatGPT when they think about AI, or more generally generative AI, but AI really is a huge suite of algorithms or automated decision-making systems that get captured in these two words. And we are using in this project a set of what are called classification algorithms, whether they are unsupervised or supervised. So in the little diagram here, algorithms automatically sort social media content into quote unquote useful categories. Some of them have predetermined categories. That is, they're supervised. In other words, you create a taxonomy and you say, here are a million posts, sort them into these categories. Some of them are unsupervised or emergent, and that's what you see on X/Twitter with trending topics. So the data really determines what topics pop up. And as I mentioned, they can require an enormous amount of data. Some of that data might need to be pre-processed. So there's huge overhead in that. For example, with supervised classification, you need to train the models. This is the same thing with generative AI. And you can go to the next slide, Drew. So you may need to train these models on massive amounts of data, and you need to do human annotation of that training data before you put any unknown data in. So this is an example of the traditional supervised classification for crises. This is supposed to be generic to crises. So for any crisis, this helps out crisis managers to be able to find out how many people are talking about injured or dead people, whether people are missing or trapped, whether they're displaced, infrastructure damage, donations, caution and advice, thoughts and prayers, those sorts of things, so on and so forth. What it isn't immediately apparent in this is almost all the data, maybe 90% of the data, gets shoved into the last couple of categories. So you actually get very few that are put into these categories, the categories near the top. And for the very top one, that is great for what Imram et al. Treated on, which was earthquakes and floods, but not necessarily for the kinds of weather that we may need to think about in northern climates. Next slide. So traditional AI, or rather the supervised classification for automatic detection, doesn't necessarily work well for northern climates. So as I alluded to, there was no snow in the original training data set. The data sets came out of Pakistan, for example. Hot countries, well, Pakistan has mountains, but tends to be the cities and hot areas in the cities and not in the snowy areas. So we might need a different data set. One of the other problems is that there are very few tweets in some Canadian places. And for those of you who are francophones in the audience, there may be a few. Francophones, as opposed to Anglophones, tend not to use Twitter/X as their primary means of conveying information or exchanging information with each other, which means that it's not very good for unsupervised classification where the topics bubble up if you don't actually have a lot of data to look at. Crisis management categories tend to be for first responders. So they may capture the management. Oh my God, there is a person trapped under a building, but it doesn't necessarily handle the disruptive weather events, the events that annoy people and may even cause some politicians to lose their jobs because they're not being sufficiently quick in their response to, for example, snow emergencies. So our job is to try to fix that as best we can. Next slide. So here are the places that we collected data. This is from Twitter data. And you get some sense of the number of tweets we collected. And we were looking at original tweets. We were looking at replies to those tweets. Next slide. We collected data. We filtered the data based on hashtags. Here's an example of some hashtags from Ontario. Notably, I have a couple in red. ARWX actually, for some odd reason, popped up in Ontario. That refers to Arkansas weather. MB Storm refers to Manitoba weather. Why those popped up is just an example of the noise, the sheer amount of noise that you get in this data set and how you have to spend a lot of time parsing the data set to get some value out of it. Next slide. We also collected data from official alerts. And by the way, many of the hashtags we collected were also official hashtags. So OnStorm, Ontario Storm, is an official hashtag from the Ontario government and also from Environment Canada. We also were interested in collecting data from official alerts. Drew mentioned specific area message encoding, like blizzard warnings, extreme cold warnings. You have an example on your right of some of these. I don't think we're going to have any tsunami warnings anytime soon in Quebec or typhoon warnings, but you get some sense of the wide range of warnings in these data sets. The question is, how are, in this case, X or Twitter users seeing and interacting with hashtags, with same alerts, same warnings, and how can this interaction inform the strategy of public authorities to improve their outreach? Next slide. Which comes back down to a basic question, and this is surprisingly difficult to answer. We talked to a number of people at Environment Canada, and we asked them, do you know where people are getting their weather information from. And one of the weirdest answers was, we get it from our watches. We get it from our phones. Obviously, this is not where people are getting their weather information from. Now, it'd be good if they said from, say, the Weather Network, at least that was a source. And, it'd be nice if it was also, we're getting it from Environment Canada, but the public does not have a very good insight into where the origin of this data. So we're trying to figure out, is anyone listening to these alerts? Next slide. So one of the first things we find when we look at our data sets is no, they're not interacting. And by interacting, what we mean generally is, are they engaging with it? And by engaging, are they replying? Are they retweeting it? Are they sharing it? And we can track that. And unfortunately, you see those big blue pies. Nah, not really. There's no interaction. So well over 50%, near 70% for same alerts, no. Next slide. That being said, it is somewhat heartening to know that if they are listening, they're at least listening to experts. And they're not necessarily saying, well, my bud down the street said this, so therefore I'm going to take that person as the weather expert. Although this is not to drag people who, one of the interesting things about the weather community is there are very well-known amateur meteorologists or retired meteorologists. And sometimes it's difficult to distinguish between an expert amateur or an official source. Next slide. We ran a lot of bivariate X and Y to bivariate. So we ran a lot of bivariate statistics on what types of warnings people were listening to. And it was quite interesting for us that storm warnings elicited somewhat more responses than blizzard warnings, but then again, there are fewer blizzards than storms. But it is interesting to get some landscape of what people were listening to. Next slide. Although I should say that winter weather advisories, maybe they should be engaging with those a little bit more. One of our next tasks was to create a taxonomy of northern climates. Now, you may recall that big table from Imran, which had all of those categories. And what our argument was, fortunately for us, we had, like you, Quebec, Montreal was inundated with snow, possibly not as much as Iowa or rest of the Midwest. But we have a lot of snow at the moment. Fortunately, not a lot of people get killed or buried under avalanches as they might if they were skiing. So we wanted to create a taxonomy of northern climates that reflected how people were being affected. Next slide. So back to an unsupervised classification. This is, there are all these tools emerging as we speak to try to capture and cluster and get a sense of what people are concerned about. And this is a tool called Atlas Nomic, and what it does is automating labeling of it. So it clusters the data, the tweets, and then it automatically labels them. And you can get a sense from this mapping that people are reacting in various ways to weather, but not the same way that Imran suggested it should be categorized. For example, stay safe and home, snowed under cars, neighbors helping, wind speed information, falling trees, power outages. Next slide. We did numerous classifications to come up with our taxonomy of northern climates. And the red box I have down here is how all of those categories of IMRAM for us got categorized just to one single category, which was casualty, where for many people, some of the greatest disruptions were around power outages, road closures, public transit interruptions, closures of businesses and schools, or remediation. I don't know how many of you have been to Montreal. When we remove snow, we don't joke around. We actually vacuum snow up into 18-wheelers. It's quite amazing to watch it in action, the front loaders that we use and the vacuum cleaners that we have and the little little sidewalk cleaners that we have to attack the snow. So remediation becomes incredibly important. And these are categories that were not necessarily captured by the traditional, what's called the gold standard of supervised classification, those categories that you put things into. Next slide. We then applied generative AI. We started with BERT in that's bidirectional encoding. And then we moved on to GPT 3.5, that's ChatGPT. And I wanted to demystify generative AI just a tiny bit because it's not magic. It's not artificial general intelligence. It's not going to be sentient anytime soon, no matter what Sam Altman tells you from OpenAI. What it does is it creates an enormous matrix of one word and a probability of its association with another word. So you may have the word turtle, and the word turtle is connected to slowly crawled SEP, or separators for phrases, and CLS is when a sentence might start. But you have this gigantic matrix, and this gigantic matrix has probabilities of what's the association between the and any other word, rabbit in any other word, quickly in any other word, hopped in any other word, so on and so forth. But you do need to pre-train it. So you may have heard that these GPTs, or generative pre-trained transformers, that's what GPT stands for, and the chat is the conversational user interface that's put on top. It's not magic. It is doing these transformations. It is exceedingly good at it because it has all this data that it is trained on. And, you know, we can be quite, not simplistic, but we tend to write more or less in the same way all the time. So you can see how these relationships can be quite strong and ease GPT's ability to do the prediction. Next slide. I wanted to give you some sense of, now many of you have used ChatGPT. I want to get you some sense of how researchers can use ChatGPT or GPT 3.5 or GPT-4. We don't use the same interface necessarily, so we're not using the chat part of it. So our prompts can be very, very long, but this is a prompt to digest the taxonomy that we created. Oops, go back, Drew. To digest the taxonomy that we created into the hello, GPT 3.5, would you please take all this data I'm about to give you and categorize it? into these categories, and this is what the categories should do. And you can see how powerful the matrix is, not talking about red pill versus blue pills. I'm talking here about these association of one word to another, or one phrase to another phrase. So you don't have to match the exact word. It gathers from these relationships, the semantics. Next slide. And I'm going to give you, more or less end with, well, some challenges too. How good it can be, and how much work we still need to do. So, tweet, road closure. Main Street will be closed from Bronte to Ontario Street. This closure is to allow for snow removal. Please keep vehicles off of the streets. All of that gets classified as service interruption. You will notice the word service interruption never appears in this tweet, and yet it got classified as we would have classified it, as a service interruption. Next slide is frozen. Sorry. Next tweet. Sorry, Drew. Next tweet is working through wind, rain, and snow, road reconstruction, slope stabilization, and culvert installation. Gets classified as a resource. So you can see that there could be some difference of opinion of whether or not this is remediation or a resource. But here, we have directed ChatGPT to not be mutually exclusive, to say you can put it in more than one category. Next slide. Hopefully tomorrow the roads are better. It was a lovely walk, well climbed, saw 3 cars stuck. Gets translated into remediation or possibly other impact. Tweet, many are hunkering down as snow blankets the province today. Thank you to the crews who are working hard to clear the roads and keep us safe. It's translated to remediation because it's picking up road crews here and clear roads. Next slide. I like the expansiveness of both the tweets and the ways in which they can be categorized. So I will skip down to the lower 2 tweets. Efforts are underway to save the fishing vessel, the Executioner, currently sinking in St. John's Harbor, was a weather alert, and was rather than say this is totally useless, because that's another category. They don't have to always categorize everything. The GPT said it is possibly useful. It is possibly an impactful tweet. And the last one, I love the snark of this. I forgot to add in 1 arse over tea kettle from yesterday before I saved the graphic. I did a full-on Home Alone slip on some ice hidden under the snow. And that was weather information, a caution, and another impact. Next slide. So, I mean, GPTs have been transformative in multiple ways, but also in the way that we could start to categorize this information because it provides semantics. But there are challenges. Next slide. How do we know the generative AI is any good? Just because it can do it, just because a couple of our samples look good, how do we know that it actually is performing? So we have been doing tests with humans to look at the results, and we then compare them to ChatGPT. We've been using Mechanical Turk, which produced the humans did not agree when we crowdsourced this stuff. One of the things that's showing up in the literature is that increasingly the crowd workers are using ChatGPT to do the crowd work. And we suspect the same because our crowd workers, we can do analytics, and they were was nanoseconds to do the classification, and humanly cannot do that. So we're trying to understand or evaluate if generative AI is good, and the generative AI itself is taking over some of our ability to do the evaluation. So we have been adjusting categories to try to address some of the overlaps and the ambiguities, and we're doing another round of human testing. Next slide. What do we do about X? I can't tell you how many researchers have bet the farm, have bet their research on using X, using Twitter data to look at how people are responding in real time to crises. And I don't have to tell you about the challenges with using X now, not the least of which is we used to have bigger research pipelines into it through what are called APIs or application programming interfaces, less so now. So we have been looking at different kinds of platforms, none of which are perfect. Next slide. So this is the end, folks. So our takeaways are we're trying to move away from top-down applications of crisis management to put more emphasis on helping weather-affected people and in northern climates. And we're focusing on listening and how people are listening to officials as opposed to merely reacting to improve the utility of weather alerts. We're trying to assess the effectiveness of generative AI to classify the posts. And we're building a dashboard to help officials see in real time how the public responds. And that's it for me and for our talk.
Excellent. Thank you so much, Renee. Thank you, Drew. Really appreciate you sharing your work here. I know we have a number of folks who've been asking some questions and providing some comments in real time. Thanks, Drew, for responding to some of those already. Now's the time. We have an opportunity here for some questions. If you have any questions for our speakers tonight, feel free to drop those into the Q&A feature here that you find at the bottom of your toolbar here on Zoom. And as we start to compile some of those, I kind of had a question, maybe for both of you, Renee, and for Drew. I mean, going through this research, I mean, you may have hinted at it a little bit throughout, but I mean, what have been, I guess, some of the biggest surprises maybe that you've kind of come across as you've gone through some of your work investigating some of these social media posts and the responses to extreme weather events?
Drew?
Yeah, I'm trying to think of big surprises. I mean, I think some of the surprises I've noted have been mostly in the way that the communities engage with around weather alerts on social media. What those networks, as I referenced from our first grant, the first 3 years of this project, it's very surprising to find, how different actors within a community relate to one another, and how messages from a given topic on Twitter can span all the way across the world, can be tied in from, a celebration in South Africa into a hashtag you might be using in Quebec or in Ontario when you're doing research on a storm up there. And it's, to some extent, it points to the noise of data. And I think anybody who's ever done scientific research has found that data, once you get out of the statistics classroom, data is never clean. It's never easy to work with. But I think with social media and big data in general, this is a really, important piece of it. How do you get this data to a state where it's useful and then can actually be put into these classifications that Renee has been talking about? I don't know, Renee, if you have other ones that you're thinking of.
Well, I think I'm also looking at Kenneth White's comment, which is very interesting, the last one. And I'll start with the answer to Kenneth's first. It says, I'm not a user of social media, but I understand why one has to retweet or like or dislike a warning for it to be considered a response. I mean, one of the challenges in research is that you're often using a surrogate or you're using a proxy for social media interactions. So think about how, how are you panicked about the latest weather warning? You can't easily ask 1,000 people. You have to go to various kinds of outlets. They're all platform dependent. People used to rely more on Facebook, but Facebook is not a real-time platform in the sense that people don't respond with the immediacy. And that's one of the problems with Twitter. There is no replacement for Twitter in how people used to use it. Even Threads is not a good a good substitute. But that being said, you're limited by the platform in how you use it. And people have been quite creative in how they use it. But, it is what it is. And, that's why we do spend a lot of time in trying to establish rigor about what we mean, for example, by interaction. When I worked with this, I was initially surprised, as I mentioned, that how Environment Canada, our national agency, does not know where people get their weather data from and how much they rely on the next tier down. And, Mount Washington Observatory actually does, has some of that public outreach component. But, it's almost like Environment Canada is like, well, we want to interact with the public, but you don't listen to any replies on Twitter. So, but so they're using it as a broadcast entity. They're not actually using the two-way functionality and the resistance. And there's always, whenever someone does social science, there's always this tension between physical science and social science, especially amongst climate scientists and meteorologists. Less so meteorologists and climate scientists. We can't really engage the public because all we're interested in is the pure science. And at Environment Canada, the Canadian Meteorological Service, our job is to analyze like the atmosphere, and whatever another entity does with it, well, they're going to just deal with it. And to me, there is this weird kind of mix of, we want to know how the people are engaging, but we don't want to know how the people are engaging with it, and how to bridge that institutionally, as well as trying to get some sense from people on the front lines of what they're doing.
It's interesting, you bring that up, Renee, because even just in a very small sample size of the 7 people we had over on the mountain for a program overnight last night, polling the audience, we're talking about, everyone was curious about the forecast, about travel impacts because of snow. And I stopped myself before showing some weather resources, and I was curious, where do you all get your weather from? And it runs the gambit, but I mean, there are so many different outlets, and our National Weather Service here in the United States is a wonderful resource and perhaps very underutilized in terms of the resources they provide. But the effort there to really interact with the public may or may not be so great, or maybe not as effective as broadcast meteorologists on social media or other more public facing folks.
Yeah, Brian, the interesting jewel in the crown of NOAA, for example, is the extent to which it relies on citizen scientists to collect data. So engagement spans a lot more than just reaction too.
Absolutely. And we had some folks who are proud COCORAS citizen scientists and participate in lots of other ways, have a home weather station, etc. There's a question that Karen just posed here that Drew may or may not be something you can comment on, but Karen was kind of curious from Mount Washington Observatory standpoint, for weather modeling, does it incorporate AI, or are they sort of the same thing, or where does that cross over? Because I know that certainly came up even just in other discussions I've had with other folks. Curious about that.
Yeah, as far as I know, we utilize a lot of the weather models that other forecasting agencies utilize, as well as our own specific data from our regional Mesonet. There are instances of AI being used to do forecasting. There's a wonderful article that came out just in the last few months um, looking at that. But I wouldn't say that it's predominant in the field. It doesn't mean that AI hasn't touched some of the data that goes into models at this point. I think that that's probably actually likely the case. But at this point, I don't see a lot of AI in the models themselves. And that may be an innovation that's coming. So it's an interesting
Yeah, let
question.
me just add to that.
Yeah.
Yeah, the primary use of AI vis-a-vis weather is called numerical weather prediction, and it is not used in a lot of places. And one of the big reasons why is code. The Drew mentioned models. The code that is involved in writing those models is enormous. Millions of lines of code. It's could be C++, it's often in Fortran. It is very hard to integrate numerical weather prediction into some of these atmospheric models. And really, a lot of NWP work is done with interpolation. So because there are, relatively few sensors for the granularity of data that people want. That's how it is used. It takes the data that comes out of these atmospheric models and then further analyzes that.
Interesting. I know just even from from the emails and inquiries we get here at the observatory as well, certainly from an academic sense. I know our team more and more are getting requests from budding minds, from young researchers, from established researchers who are looking for large data sets to also work with and train their models or test out some sort of hypothesis that they're working at. So it's definitely coming. There's a lot of interest. We're certainly aware of that in terms of what the observatory's data sets can provide. Curious to see where that all goes and certainly how we can support some of those investigations. Great question here from Peter Crane. Many of you may know, certainly know him from down the hall here in the office. Peter asks, will there be options in the future use of AI for organizations such as Environment Canada to interact with citizens in an immediate and maybe AI personalized way, overcoming the limitations of human staffing levels? Interesting question.
Well, the only AI that I know of at the moment is the use of AI to do what's called passive harvesting of public feedback. So oftentimes when you start an initiative to gather public input, you get thousands and thousands of replies, and how you can't visually inspect all of those. So you can use machine learning as a subset of AI to the same way that Nomic, that mapping did, was to see what clusters of topics there are. But I think Environment Canada, probably because of the limitations of human staffing, leaves it to other entities like the weather networks or Meteo, Quebec, to do the personalization, and they probably use some machine learning, but the machine learning is not that complicated.
All right, so we'll see, Peter. You may just have to wait a little bit longer for now, or at least with the Mount Washington Observatory for the time being. It'll be somewhat more manual. Well, we're just about running into 8 o'clock here. Would like to acknowledge Rick giving the shout out for Kokoraz, a proud contributor there. Wayne, who has joined, and saying a big thank you, joining us from Halifax, Nova Scotia this evening. Thanks for joining. And Jim asking, we can't leave without this. Jim wants to know, what were the answers to the poll questions? Did we skip right by those?
Yeah, I can certainly provide the answers. So if you want to have a drum roll, Brian.
All right, here we go.
So obviously the first question, the answer is wherever you're from is perfect. But number two, the answer here is machine learning is typically what is considered to be algorithms that improve automatically through experience. AI was first called artificial intelligence in 1956 at a conference of academics and began being studied formally at that point in time. So most people were correct on that one. And then similarities, I think most people were spot on our last question, but obviously the climate was the correct answer there.
I'm sure welcoming people was certainly an acceptable answer.
I think welcoming people would have sufficed also.
A little bit of a trick question, in my opinion. Excellent. Well, thank you, Renee. Thank you, Drew. I really appreciate your time and for sharing this really fascinating work. I know lots of appreciation from everyone joining tonight. If you enjoyed tonight's free program, we would encourage you to make a donation over at mountwashington.org, where you can hit the donate button to support free programs like these and the rest of our work here at the Observatory. If you have some thoughts about tonight's program or suggestions for a future Science in the Mountains lecture, please take some time. We'd appreciate you filling out our Google Form survey. That'll show up in the Zoom window following this program. And then finally, don't forget to join us next month for Science in the Mountains. Tuesday, February 20th at 7 p.m., we'll have Fairfield University Associate Professor Robert Nazarian, who will share his work on future precipitation trends for the northeastern United States. So don't forget to register for that program. You can catch up and watch any previous programs you may have missed over at mountwashington.org. And everyone, have a great night. Thanks so much, Renee. Thanks, Drew.
Thanks, Brian. Have a wonderful night, everyone.
Bye.
Take care.
Pleasure. Bye.